this in Algebra 2, and probably do it a little more in pre-calculus. Okay, so first of all, I'm going to define. So an arithmetic sequence is a set of ordered terms, and some of the words in the definition are going to need to be defined as well. I'll do that right after. A set of ordered terms that have a common difference. Okay, so what do I mean by a set of ordered terms? So you can have a set of elements, of course, that don't have to be in any particular order. So I'll just say like A, B, C, D, E. But you could reorder that set B, D, E, A, C. It's the same set. Order doesn't matter, at least for just a set. But if I say it's ordered, if I say the set is ordered, then the order does matter. So then these two sets would be considered different sequences. Okay, so we've got a set of terms and the order matters. And in addition to that, the terms have a common difference. What does that mean? Okay, so let's say my set of ordered terms has the first term A1, I call the second one A2, and the third A3, and the fourth A4. Okay, so this is my set of ordered terms. Now I'm going to add to that the requirement that the second term, A sub 2, is really A sub 1 plus some value. And another requirement is that A sub 3 really is A sub 1 plus 2 of those D's. So I add an additional D to the second term to get the third term. So that's my third term. And then the fourth term is really A sub 1 plus 3D. So now my sequence is now called an arithmetic sequence. The word arithmetic, arithmetic can really refer to anything involving addition, subtraction, multiplication, and division. But in this context, arithmetic means addition. So each term is attained by adding a D, an extra D, an extra D. And that's what constitutes an arithmetic sequence. Okay, so here are a couple examples. So you could have a sequence 18, 15, 12, 9. This is an arithmetic sequence where D, well, I'll start with the first term. A sub 1 is 18, and your D value is -3. The D value is not 3 because we always talk about arithmetic sequences in terms of addition. So I don't want you to think in terms of I'm subtracting 3 to get the next term. I'm adding -3. So my D value is -3. Another example, -24, -11, 2, and so on. So these values are getting bigger, so I'm adding a positive number. My A sub 1 is -24, and my D value is 13. Okay, so there's a couple examples. All right, so now we're going to derive something called the nth term formula. Let me put this here. The nth term formula. This formula allows you to compute the term way down in the sequence. So let's say, here are my first few terms. let's say I'm interested in the 100th term in the sequence. And let's say my d value is known. I'll put a check mark to say it's known. Well, I could just keep adding the d value over and over and over again till I get to the 100th term, but that, first of all, would take a while, and I could speed up the process by using multiplication, since the multiplication is repeated addition. But I would like to be able to use the same process no matter how far down the road the term is. Whether it's the 100th term down the road, or the 1000th term, or the 10,000th term down the road, I like a common process. So that's where the nth term formula comes in. So to derive this, I'm going to rewrite the terms of a general arithmetic sequence like so: a sub 1, a sub 1 plus d, a sub 1 plus 2d, a sub 1 plus 3d, and then dot 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 for all the successive terms, all the way to a sub 1 plus d times, and I'm going to leave this blank for the moment. So above these terms, I'm going to write your ordinal number. An ordinal number is just the position that these terms have in the sequence. This is the first term, so the ordinal number is 1. This is the second term, so the ordinal number is 2. This is the third term, so the ordinal number is 3, and so on. So what I want you to notice is that in each term, the coefficient of d is always 1 less than the ordinal number. And that should make sense because in each term you already have a sub 1, right? A sub 1 is part of the composition, the DNA of each term, and you're adding to that a certain number of d's. The first term doesn't have a d to it because the first term is just a sub 1. The d's don't start until the second term, so the first d is in the second term. The second d, or the two d's that are added to a sub 1, are in the third term, and so on. That's why the coefficient of d is always 1 less. So when I get to the nth term, n stands for some ordinal number, like a very high ordinal number down the road. When I get to the nth term, the coefficient of d, which I'm going to put in the parentheses right here, is 1 less than it, so it's n minus 1. So that means any term down the road I'm interested in, which I will call the nth term, any term I'm interested in down the road, even if it's 1,000,000 terms down the line, is always going to have this makeup, this composition, this DNA. A sub 1 plus d times n minus 1, because the coefficient of d is always 1 less than the ordinal number. So let's try this out. Let's say I have a sequence 3, 6, 9. It's not too hard to see that the common difference is 3 there. And let's say I want to know a sub 50. What is the 50th term in the sequence? And I could do it manually, of course, but let's, for the sake of practicing this formula, let's plug everything in this formula. A sub 1 is 3. D is 3, and n minus 1, since I'm interested in the 50th term, n minus 1 is 49. I'll do a little quick multiplication here. Three times 49 is 147. and then I add 3 to it for the first term, and I get 150. So the 50th term in 369 dot 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 is 150. Okay, now you may think, okay, is this the only thing we can do with this formula? No. All of this equals the nth term, the term that you are interested in. But it's certainly possible that you already know a term way down the road exists, but maybe you don't know the ordinal number of that term. You're just told that this term exists down the road in this sequence, but you don't know in what position that term exists in. So maybe you're solving for n instead. Or maybe you know a term down the road and you know the position it's in. You know n, and you know the first term, but maybe you don't know the common difference of this sequence. So you could solve for d instead. Or you know d, you know n, you know the term down the road, the nth term, but you don't know the first term of the sequence. You could solve for that. So this formula is multifaceted. As long as you know 3 out of the 4 variables in the formula, you can solve for the fourth one. So let's do an example where we're solving for not for a sub n, but for something else. Okay, so let's say we know a sub n is 37. So 37 is a term down the road. And let's say we know the first term is negative 13, and the common difference is 5. So what do we not know? We don't know n, the ordinal number of 37. So let me write down the formula one more time. Okay, so 37 is a sub n, so that goes here. A sub 1 is negative 13. The common difference is 5, and we don't know n. But as you can see, we will be able to solve for n because everything else is known. I'm just doing some algebra here. Here, I'm going to divide by 5 on both sides because 50 is divisible by 5. And n is 11. So 37 is the 11th term in this sequence that has negative 13 as the first term and common difference 5. Okay, let's do one more example. Let's say we don't know d, so I put a question mark there. We know the first term is 4, and we know the 11th term is 64. 64. Okay, so again, I put 64 where a sub n goes. I put 4 where a sub 1 goes. I don't know d. And for my n minus 1, notice I didn't actually write n equals anything here, but if you look at the ordinal number of 64, you'll see that n is 11. So I'll put 11 minus 1 there. Okay, now we're back to algebra mode. Subtract 4. That's 10. So d is 6. So the common difference of this arithmetic sequence is 6. And I guess we'll do one last one. Let's say I don't know the first term in the sequence, but I do know the common difference is negative 2, and I do know that a sub 7 is 3. Okay, so a sub 7 goes there. A sub 1, I don't know at this time. Common difference, negative 2. n minus 1. N is 7 this time, so 7 minus 1. Now I go to solving mode. That's going to be negative 2 times 6, that's minus 12. And so a sub 1 is 15. So the first term in this sequence is 15. Alright, so to wrap up this video, things not to forget. What an arithmetic sequence is, of course, set of ordered terms that have a common difference. The common difference is what you add to every term each time to get the next one. And sometimes the common difference is negative, so watch out for that. And we derive the nth term formula, which is right here. And we can use this formula to find a variety of things. We could use it to find a sub n, which is what we use it most of the time for. Or we could use it to find a sub 1, or d, or n, depending on what you know and what you're asked to find. Okay, thanks for watching arithmetic sequences. Look out for the video on geometric sequences, and we'll talk to you later. Thanks for watching K109 Math.